Okay, so number one, if you do a factor tree, I just did a factor tree on 567, and I said it ended in 7. So I was like, what numbers end in 7? And I said, well, if I multiply, well, I said 7, right? So 7 goes in there 81 times, and then that's 9 times 9, and 3, and 3, and 3, and 3. So I have 4 3s in there, okay? So I know I can bring 1 3 out, and no x's and no y's, so the 4th root of 7x squared y squared. The hardest thing was the 567. And then 72, I happen to know that 72 is 36 times 2. So the square root of 36 is 6. The square root of x to the 4th is x squared. And there's nothing else can come out, so I've got the square root of 2y. 81 is 4 3s. So I can bring 1 3 out. I can bring, there's 2 groups of 3 x's in 8 and 2 groups of 3 y's in 7. So then I have the cubed root of 3 x squared y. Oh, 96. Let's see, what did I do for 96? I think 96, 16 goes in there 6 times. So 96 is 16 times 6. And 16 is 4 times 4, which is 2. 2 times 2 and 2 times 2. So there's 4 2s. So I can bring a 2 out and 1x and 3 y's. There's 3 groups of 4 y's? Yes. And that would be the 4th root of 6, and then there's 1x left, 6x. For 16, I already know is 4 2s, so I can bring a 2 out. And there's 3 groups of 4 2s and none of b's. So then I'm going to get the 4th root of a to the 3rd b squared. And then the square root of 16 is 4. The square root of x to the 4th is x to the squared. The square root of y squared is y. 150 is 25 times 6. Is that right? 6 quarters? Yeah. So the square root of 25 is 5. There's 5 groups of 2 x's and 2 groups of 2 y's. So then I'm going to square root of 6x. And then the last one, 32, is 16 times 2. The square root of 16 is 4. 1 set of x's, 4 sets of y's. Yeah. And then a square root of 2xy. Okay. There's the answers there. Anybody has any questions, please ask. Okay. So we're still going to be simplifying square roots, only now instead of multiplication, we're going to talk about division. So for any real numbers, the nth root of a and the nth root of b, where b cannot equal 0. The nth root of a divided by b equals the nth root of a divided by the nth root of b, right? And because it's an equal sign, it goes both ways. So I can either go from them both being under the square root to them being individually under 2 different square roots, or from 2 different square roots under the same square root. So I can go back and forth because they're equal, correct? So we're gonna use both of those concepts today, going from both ways. So right now we're just going to go ahead and simplify by taking square roots of the numerator and denominator, see if we can simplify it. That's it. So what's the cubed root of 81? Oh, no, this is a square root. Sorry, square root of 81 over the square root of 25. So I'm going to, basically I can say square root of 81 over the square root of 25, which equals 9 over 5. That's it. Okay? Want me to make it bigger so you guys can see it in here? Is that better? And then we're going to move on to this cube root here. So remember, I need to do a cubed root. So the cubed root of 27 is 3, because 3 times 3 times 3 is 27, right? So, well, I can rewrite this, right, as the cubed root of 27a to the 4th over the cubed root of 8b cubed. Now, this is just like what we did last class. We have 2 separate ones to do. So the cubed root of 27 is 3. The cubed root of a to the 4th is a, with the cubed root of a over 2b. Because the cubed root of 8 is 2, and the cubed root of b cubed is b. Questions? Are we okay at home, in class, the two of you? Okay. 3, same thing, right? I can do it the same thing. I can rewrite this as the cubed root of 64x to the 7th over the cubed root of 216y to the 6th. So if I write that separately, the cubed root of 64 is 4. And x to the, there's 2 groups of 3 in there. And then I have the cubed root of x over 206. I think that's 6 times 6 times 6. I'm going to check. Sorry. 6 times 6 times 6. That is 6 times 6 times 6. Yeah, okay. So the cubed root of 216 is 6. And the cubed root of y to the 6 should be y squared. And unfortunately, I can still simplify this, right? Because 4 and 6 simplify to 2x squared cubed root of x over 3y squared. Because 2 goes into 4 and 6. Questions? You guys okay with that? Or is there any questions? I know I just said questions 2 different ways. Sorry. Okay, so go ahead and do A, B, and C, please. Look on your screen.
Wait, I have a question.
Okay, Aya, what's your question?
On the one that you just did?
Yes. That one right there?
Can you just go back so I can look at it?
Yep, of course.
Never mind, that makes sense.
Okay.
It's just like multiplying, right?
Yeah.
Okay, then I have no questions.
Okay. Awesome. So can you try and do these 3 problems for me then?
I'm just kidding, yeah.
It shouldn't have taken you this long to do them. Just to be honest with these 3 problems, right? So the square root of 49 over 100 should be 7/10. And the cubed root of 125 over 8 should be 5/2. And the square root of 121 over t squared should be 11 over t. Done. Okay, so do the next 3, please. These ones will be a little bit harder. Oh, okay. I was waiting for somebody to put some answers in. I was like, oh, is it really taking this long to put these answers in? And then I'm going to pause for a second while I get little Miss Lady McLate some notes. Oh, where's the print? Oh, there's print. Okay. Oh, you guys. How are you doing? Are you okay?
Yeah, I'm good.
Okay. Okay, it's printing now. Here you go, sweetie. Whew. Oh, it's warm. We're just talking about how cold it is in here. So, huh? You don't feel cold? Oh my gosh, I'm freezing. Okay, and then we're gonna go on to the second one. I guess I could have recorded that whole thing and people would have seen that, but I don't know if I hit it on accident or not, but I'm sorry. I'm going to do a sixth root. So I have 6 x's. So I'm going to bring 1 x out. I have one group of 6 y's. And there's going to be 2 left inside. And I have 2 groups of z's. And that would be 12, 13, 14. 3 left inside. So that's going to be the 6th root of y squared over the 6th root of z to the cubed. Questions? Whew. Okay. So if we go to the next, what's the next direction say? Divide, and if possible, simplify, assume all. Okay, so we're going to divide these. So on this one, instead of separating them out, I'm going to put them back together, and then I'm going to divide, and then I'll simplify, because then I think that's a little easier. Oh, so if I rewrite this as the square root of 700x over 7x, now I can simplify what's on the inside. So the x's go away, and then I get 700 divided by 7 is the square root of 100, so that's going to equal 10. That made it much easier, right? Yeah. So we're going to do the same thing with the next one and see how much simpler that makes it. I don't know if it's going to make it a lot simpler or not. But, so I have the cubed root of 189 x to the 5th, y to the 7th, over 7x squared y squared. So that's going to become, let's see, 189 divided by 7 is 27. So this is the cubed root of 27 x to the 3rd, y to the 5th. Okay, any questions on how I got that? Does anyone know? Anybody have any questions? I just took 189 divided by 7, that's 27. And then x to the 5th over x squared is x cubed, right? Because there's 5 on top and 2 on bottom. So if I simplify, there'll be 3 left on top. Same with this, there's 7 on top and 2 on bottom. So there'd be 5 left on top, 5 y's left on top, yeah? Okay, now I'm going to do the cubed root. So the cubed root of 27 is 3. The cubed root of x cubed is x. The cubed root of y to the 5th is just one group of 3 y's. And then the cubed root of y squared, because there's 2 y's left over. And I can only combine the roots if they're the same, right? So cubed root and a cubed root, if it was a square root on top and a cubed root on bottom, I couldn't do this. They have to be the same root, okay? And then number 3, I think I can write this one as, let's see. Probably, I'm trying to figure out how I want to write this one, but I'm probably going to write this as, I'm going to write this as 1/5, and then this really ugly, I know that it kind of looks weird, AB divided by 2, so this is going to be 50, so I'm going to get the square root of 50 AB divided by 5, that is really ugly. 50 is what, 25 times 2? So it's 5, square root of 25 is 5. 2 stays inside, AB divided by 5, so that goes away, and I get the square root of 2AB. Wow, Okay. Questions? Okay, you guys, let's have you do, I kind of have them spread out a little bit on this one. So A, B, C, and D. Let's see what you make of those. Possibly, yes. We're going to go ahead and combine this together and say this is the square root of 18y over 2y. So the y's go away, 2 goes into 18. So that becomes 9 times. So the square root of 9 is 3. I so cannot talk today, is 3. And then this one becomes the square root of 40xy cubed over 8x. So the x's go away, 8 goes into 45 times. So this becomes the square root of 5y cubed, or y, square root of 5y. Okay. Nice skips. This one I can rewrite as the cubed root of 96a to the 4th b squared over 12a squared b. And 12 goes into 96 8 times. So this goes in there 8 times. The 2 on the bottom goes away and I get left with 2 on the top. B on the bottom goes away, I get left with 1b. So I get the cubed root of 8a squared b. So the cubed root of 8 is 2. And then I have the cubed root of a squared b. And then the last one I can rewrite as 1/3 times the square root of 75ab divided by 3. 3 goes into 75 25 times. And so that gives me the square root of 25ab divided by 3. And the square root of 25 is 5 square root of ab divided by 3. Done. Okay? Beautiful. And then we have the last thing that we're going to do or talk about today, which is called rationalizing the denominator. So this is like the huge debate, and I know some of you have heard this before, the huge debate in the math world right now. I know there's a debate in the math world. It's really exciting. Whether you have to rationalize the denominator, that just means there can't be any square roots in the denominator. Okay, and some people think there shouldn't be because there hasn't been up until this point, well, a few years ago when this debate started. Yes, it's been going on for a few years now. That there should not be ever any square roots in the denominator. So they always had to take all the square roots out of the denominator. And then there's people that are like, why can't we have a square root of the denominator? So that's what's been going on right now. But until they figure it out, sometimes we need to know how to rationalize the denominator. So I'm going to show you how to do that. It just means I cannot have any square roots in my denominator. Okay, so what I'm going to do is I'm going to rewrite this as 2 different square roots. So I have the square root of 7 over the square root of 2. So what I want to do is multiply this fraction by something that's going to help me get rid of that square root of 2 in the denominator. I don't want a square root of 2 in the denominator. I want a whole number, or, well, whole number includes 1. But I just want to multiply it by something. And I'm going to multiply it by 1. But it's going to be a very special one, right? It's going to be a one that's going to help me get rid of that square root of 2 in the denominator. And so what I'm going to multiply it by is the square root of 2. So I'm going to multiply by denominator by the square root of 2. And since I don't want my fraction to change value, I'm also going to multiply the top by the square root of 2, because the square root of 2 divided by the square root of 2 is 1, right? So I'm not changing the value of my fraction, I'm just changing what it looks like, and that's what rationalizing the denominator means. I'm changing the look of it, but not the value of it. So now that I'm multiplying it, and I know what I'm multiplying by, it's always whatever is in the denominator. I'm just going to make that a 1, okay? Square root of 2 over 2. If it was the square root of 5, it'd be the square root of 5 over square root of 5. Okay, is everyone okay with that? And then when we get to different roots, we're going to talk about that in a minute. So then I get the square root of 14 over the square root of 4, right? But what's the square root of 4? Well, the square root of 4 is 2. Look, no more square root in my denominator. I've cleared it out because I multiplied by the square root of 2. Any questions? Is that okay? Right, pretty easy. Okay, so let's do the next one. The next one, it's okay that there's a 7 in the denominator. The only thing that I want to get rid of is just the square root. So the only thing I'm going to multiply by is the square root of 3 divided by the square root of 3. Okay, because all I want to get rid of is just the square root. So this becomes 2 square root of 15, right? 5 times 3 over 7 times the square root of 9, which is 2 times the square root of 15 over 7 times 3, which is 21. Is everyone okay with where I got 21 at? Because the square root of 9 is 3, and 7 times 3 is 21. Okay? Not bad? Okay, if it's a square root, it's not too bad, right? So now let's go and talk about if it's a different root. So here, I can rewrite this as the cubed root of 2 over the cubed root of 9, right? So now, remember, a cubed root means I need 3 of the same thing in my denominator. Well, if I rewrite this, I have the cubed root of 2 over the cubed root of 3 times 3. How many 3's do I need? I just need 1 3, right? But if this was only the cubed root of 3, I'm going to erase this for a second. If this was just 3, I would need 2 3's in there to make a cubed root go away. Does that make sense? So how much ever I need in there to make it go away is how much I'm going to multiply by the root. In this case, I only need 1 3 because I've already got 2 in there. So I'm going to multiply by the cubed root of 3 over the cubed root of 3. So I'm going to get, let's see, what am I going to get? The cubed root of 6 over the cubed root of 27. So that's the cubed root of 6 over 3. Okay, I'm going to have you guys try. I think this is our last thing that we're doing. It is. Okay, you guys try that. There's a couple of them that are a little harder, B and C, but not too bad. On the first one, I'm going to multiply by square root of 7 over square root of 7. So I should get 3 square root of 35 over 14. Okay? Nice. And then on the second one, I'm going to multiply by the cubed root of 2 over the cubed root of 2. So I should get the cubed root of 10 divided by 2. And then on the last one, I'm going to multiply by the cubed root of 25c squared. So that's going to give me the cubed root of 75ac squared all over 5c. Questions? Is that okay? Okay, so that's it for today. You have a Delta math lesson. I think it's 12 questions today. It's pretty short compared to what the other ones have been. So we've got a 10-ish, 18-ish minutes. How long is it? Oh yeah, 19 minutes to work on Delta math. That's pretty good. Nice. Nice, nice, nice.